Hey guys, welcome back to the channel. This is part 5 of the oscilloscope overview. We left off on page 70 of the manual, and today is going to be going through the rest of chapter 5. So next up we have slope trigger. It says the slope trigger, the oscilloscope triggers on the positive or negative slope of the specified time. The trigger mode is applicable to ramp and triangle waveforms. Press type, then rotate the multifunction to select slope and press down the multifunction. So we're going to go to menu, then we're going to go to type, and we're going to rotate this down to slope and press slope. It says the trigger setting information is displayed at the upper right corner of the screen. The trigger type is slope trigger. The trigger source is channel 1, and the difference between the upper limit of trigger level and the lower limit of trigger level is on mine, which is right here in the upper right. It says 0 millivolts. So that's the waveform, that's the channel, and this is, oh, it says 40 millivolts. My bad. Okay, so that's the trigger difference between the upper limit and the lower limit. And so that'd be 40 millivolts. Source selection. Press source to switch to signal source and select channel 1 or channel 2. So we've already gone through that with the other ones. In this oscilloscope, positive slope time is defined as the time difference between the two crossing points of trigger level line A and B with the rising edge. Negative slope time is defined as the time difference between the two crossing points of trigger level line A and B with the falling edge as shown in the figure below. Okay. It tells you the different conditions for the slope, which would be when, and it tells you how to use these. So it says the time is varied on each of them, so you have to pay attention to the time setting when you do change. When you do change when the slope is set, then you have to pay attention to the time because it'll change. You can also change it on the vertical level, which is this right here. Okay, the first one is only adjust the upper limit of the trigger level. The second one is only adjusts the lower limit of the trigger level. And the third one is adjust the upper and lower limits of the trigger level at the same time. So those are the 3 different vertical window variations. Okay, next up we have video. Video trigger. So we're gonna cancel all of that. Clear. So we're already in the menu, so you would go to video. It says the video signal can include image information and timing information and can adopt different standards and formats. The oscilloscope can trigger on the standard video signal or line of the National Television Standards Committee, PAL, phase alternating line, or SECM, sequential collier et mémoire. It says press tab, rotate the knob to video, and press down. At this point, the trigger setting information is displayed in the upper right hand corner of the screen, which we know is right here. So this is the waveform for video. It's on channel 1, and the range is -40 microvolts. Okay. Then you can press the source to change the source, which is channel 1 or channel 2. Next you can change polarity to select the desired video polarity. Polarities available are positive polarity and negative polarity. So this is negative, positive. So positive or negative. Okay. Next up you have press sync to select the desired sync type. All line trigger on the first line found. Line for NTSC and PAL SECM video standards. Trigger on the specified line in the odd or even field. When this sync trigger mode is selected, you can modify the line number using the multifunction in line menu with a step of 1. The range of the line number is from 1 to 525 for the NTSC and 1 to 625 for the PAL SECM, 1 to 525 or 480p, or 1 to 625 or 576p. So that's this sync button, and it tells you the range of each one. That's what I just told you. And then you have even. Okay. Odd, trigger on the rising edge of the first ramp pulse in the odd field. Or even, trigger on the rising edge of the first ramp pulse in the even field. Okay. Press standard to select the desired video standard. NTSC, the field frequency is 60 fields per second, and the frame frequency is 30 frames per second. The TV scan line is 525 with the edge field goes first and the odd field follows behind. So that's here standard. It says PAL Seacom. PAL, the frame frequency is 25 frames per second. The TV scan line is 625 with the odd field goes first and even field follows behind. Seacom, the frame frequency is 25 frames per second. The TV scan line is 625 with interlaced scan. For 480p, the frame frequency is 60 frames per second. The TV scan line is 525 progressive scan. The line frequency is 31.5 kilohertz. So we'll go to that one. .576p, the frame frequency is 60 frames per second. The TV scan line is 625 progressive scan. Okay, next up on the type we have the runt. So we did skip pattern, duration, and now we're going to go to timeout. We're going to go to runt. This trigger mode is used to trigger pulses that pass through one trigger level but fail to pass through the other trigger level as shown in the figure below. Okay, and this is shown in the upper right hand corner, which is right here. Runt, and then channel 1, and then 40 millivolts. You can press polarity to select the pulse polarity of runt trigger. This being the positive and the other one being the negative. You can trigger when the runt pulse width is greater than the lower limits of pulse width. So that's going to be your qualifier. And then you're going to change it to pick the type of conditions to trigger the runt. So the first one is when the runt pulse width is greater than the lower limit of the pulse width. The second one is when the runt pulse width is lower than the upper limit of the pulse width. And the third is when the runt pulse width is greater than the lower limit and lower than the upper limit of pulse width. So you're going to change the vertical window and the trigger level to adjust the trigger level to correctly trigger the signal and obtain a stable waveform. And you're going to do that by changing the window, which is this one. So the first one will only adjust the upper limit of the trigger level. The second one only adjusts the lower limit of the trigger level. And the third one adjusts the upper and lower limits of the trigger level at the same time. Okay. Next up we have window. Window trigger provides a high trigger level and a low trigger level. The instrument triggers when the input signal passes through the high trigger level or the low trigger level. Okay, you're going to select the window type right here. And the first one, oh no, that's wrong. you're going to select the window tap right here. And the first one is trigger on the rising edge of the input signal. The second one is trigger on the falling edge. And the third one is trigger on any edge of the input signal when the voltage level meets the preset trigger level. Okay, next up is the delay one. Oops. In delay trigger, you need to set a signal source A and a signal source B. The oscilloscope triggers when the time difference between the specified edges of a source A and source B meet the preset time limit, as shown in the figure below. Okay. Press source A to select channel 1 or channel 2, then press source B to select channel 1 or channel 2. So this is when you're looking at two different signals. And you'll select the channel for each. So you select channel for source A, and then you'll select a channel for source B. And then you select the edge, and that's the rising or the falling. Okay, the one we're looking at is falling, and this one's rising. Okay, if you can't remember, just look at the arrow. So that's going up, so that's rising. That's going down, so that's falling. Just look at the little diode symbol. Okay. The delay tap is set to time limit condition of delay trigger. So you would pick the type of delay you're looking to measure. And you would pick it here under delay tap. The first one being when the time difference between the specified edges of source A and source B is greater than the preset time of the lower limit. The second one would be when the time difference between the specified edges of source A and B is lower than the upper. The third one is source A and B is greater than the lower limit of the preset time and the lower than the upper limit of the preset time. The fourth one would be, this fourth one would be when the time difference between the specified edges of source A and source B is lower than the lower limit of the preset time or greater than the upper limit of the preset time. Okay. Next up, press setup hold trigger. So that's the next one. Oops. It always does that. In setup hold trigger, you need to set the data signal line and clock signal line. The setup time starts when the data signal passes the trigger level and ends at the coming of a specified clock edge. The hold time starts at the coming of the specified clock edge and ends when the data signal passes the trigger level again, as shown in the figure below. The oscilloscope triggers when the setup time or hold time is lower than the preset time. Okay. Press data source and clock source to set the signal sources of the data line and clock line, respectively. So this would be your data source. You pick which channel. Next, your clock source, pick which channel. Then you're going to press slope to select the desired clock edge type and set it to rising or falling. So it would be down here, rising or falling. Okay. Set the data type to a pattern of high or low. And the setup type, which is this. Setup, the oscilloscope triggers when the setup time is less than the specified setup time. After selecting this type, press setup to set the setup time and the range from 8 nanoseconds to 1 second. Hold. The oscilloscope triggers when the hold time is less than the specified hold time. After selecting this type, press hold to set the hold time and the range is from 8 nanoseconds to 1 second. Setup, hold. The oscilloscope triggers when the setup time and the hold time are less than the specified times. After selecting this type, press setup and hold to set the setup time and hold time respectively, and the range is from 8 nanoseconds to 1 second. Okay, nth edge trigger is our next one. Trigger on the nth edge that appears after the specified idle time. For example, the instrument should trigger on the second rising edge after a specified idle time, the time between two neighboring rising edges, and the idle time should be set to P, idle time, then M, wherein M is the time between the first rising edge and its previous rising edge, and P is the maximum time between the rising edges participate in the counting. So it has rising edge or falling edge. It has the idle time that you're gauging. It has, let's see, the edge number. You can press edge to set the value of the nth edge trigger, and the range available is from 1 to 65,535. So if you need to choose the last of 65,000, then you can change it right here. Okay. The range for idle time is 16 nanoseconds to 10 seconds. Okay, next up is the RS-232. RS-232 bus is a serial communication model used in data transmission between PCs or between PC and terminal. Okay, let's see that one. RS-232 serial protocol, a character is transmitted as a frame of data which consists of 1 bit start bit, 5 to 8 bits data bits, 1 bit check bit, and 1 to 2 bits stop bits. Its format is shown below. The oscilloscope series triggers when the start frame, error frame, check error, or the specified data of the RS-232 signal is detected. So you can press your source, it's shown up here as 232. Your channel, you can choose the polarity. So it can be set to positive or negative, positive or negative, and the default is positive. Okay, you can press Win to select the desired condition. So press Start to trigger it on the start of the frame position. Choose Error to start it when error frame is detected. And after that trigger condition is selected, press Stop Bit to select 1 bit or 2 bits. Press Even or Odd to select None, Odd, or Even. You can choose Check Error, and that'll trigger when the check error is detected. You can choose Data, trigger on the last bit of the preset data bits. You can press data bits to select the amount of data bits, so 5, 6, 7, 8 bits. You can press data to set the value and according to the data bit setting. And ranges can be from 0 to 31, from 0 to 63, from 0 to 127, or from 0 to 255. You can set the baud rate of the data transmission, so press baud rate to set the desired baud rate to, and that's this one. So you can set it to 2400, 4800, 9600, which is the default, 19,200, 38,400, 57,600, 115,200, 230,400, 460,800, 921,600, or 1 megabytes per second in user defined. When user is selected, press Setup to set a more specific value from 110 to 20 million with an adjustment step of 1 bits per second. For the setting method, refer to the introduction and parameter setting method. Okay, next up we have the I2C. And close that. Okay, I2C is a 2-wire serial bus used to connect the microcontroller and its peripheral device, and is a serial bus standard widely used in the microelectronic communication control field. The I2C serial bus consists of SCL and SDA. Its transmission rate is determined by SCL and its transmission data is determined by SDA. As shown in the figure below, the oscilloscope triggers on the start condition, restart, stop, missing acknowledgement, specified device address, or data value. It can also trigger on specific device address and data values at the same time. Okay, you can select your source as SCL and SDA. So SCL being the first and SDA the second. And you pick which channel each is on. Okay, when. Press when to select the desired trigger condition. Start. Trigger when SDA data transitions from high level to low level while SCL is high level. You choose restart to trigger when another start condition occurs before a stop condition, or choose stop to trigger when an SDA data transition from low level to high level while SCL is high level. Okay, and that's here. Then you can choose missed ACK, trigger when the SDA data cable is high level during any acknowledgement of SCL clock position. The next is address. The trigger searches for a specified address value. When this event occurs, the oscilloscope will trigger on the read-write bit. After this trigger condition is selected, press address bits to select 7 bits, 8 bits, or 10 bits. Press address to set the address value of I2C trigger. According to the setting in address bits, the range can be from 0 to 0 by 7F, from 0 to 0 times FF, or from 0 to 0 times 3FF. Press direction to select read-write or read-write. It's not available to select direction when address bits is set to 8 bits. Next, you can select data. The trigger searches for specified data value on the data line, or the SDA. When this event occurs, the oscilloscope will trigger on the clock line, SCL, transition edge of the last bit of data. After this trigger condition is selected, press bit X to select the desired data bit, and range is from 0 to byte length times 8 to 1. Okay, next up is A and D. The oscilloscope searches for specified address and data at the same time and triggers when the specified address and data are found. Okay, and then you can press address bits, address bits, and bit X, and direction on that one. Okay, last we have SPI. An SPI trigger after the CS or timeout condition is satisfied, the oscilloscope triggers when the specified data is found. When using SPI trigger, you need to specify the SCL clock sources and SDA data sources. Below is a sequential chart of SPI bus. So this one you can change your channel for the clock, and then you can change your channel for the data cable. SCL is the clock, SDA is the data cable. Next you would press data to set the data bits and the data of SPI trigger, which would be here. Change the data bits. It can be set to any integer between 4 and 32. Press data to set the value of the current bit to H11 or X. And press all bits to set the data bits to the value specified in data. Okay, timeout. The clock SCL signal needs to maintain a certain idle time before the oscilloscope searches for a trigger. So that would be here under when. And then you can press the clock edge. Which is right here. Rise or fall. And that's all of our trigger settings. So we went through all of them, except for a few. So I think that's pretty good, and at least we know all of them are on there. Which is pretty amazing, because there's a lot. Okay. We went through all of them except for 4. Maybe, actually 3, actually. So, that was pretty good. Next up it says the trigger output connector on the back of the oscilloscope can output trigger signals determined by the current setting. So let's see. I can turn it around and show you. Whoa, it's not gonna let me. And that's here, this trigger output. And that's a connector. Okay. Sorry, I'm trying to fix the scope because it's like sticking out. Okay. It says a signal which reflects the current oscilloscope capture rate can be output from trigger out connector each time a trigger is generated by the oscilloscope. If this signal is connected to a waveform display, device to measure the frequency, the measurement result is equal to the current capture rate. If you press utility auxiliary out to select pass or fail, okay, and that's gonna be right here. So you press utility. And then pass or fail. Source. Wait. I don't see where it says, oh, there it is. Okay, let me start that over again. Utility, pass or fail, then scroll down, auxiliary out. Mine doesn't. I guess you would enable that. Mine is totally grayed out on that, so I don't know. I don't know how you would enable that. It says press auxiliary out to select on in the pass-fail test. When a failure is detected, the oscilloscope outputs a negative pulse from the trigger out connector when the no failure is detected. The oscilloscope outputs a low level continuously from this connector. And that completes chapter 5. Next up is chapter 6, Math and Measurement. In this chapter, it goes over math operation, auto measurement, and cursor measurement. Okay, first up is math operations, so algebra operations, spectrum operation, FFT, logic operations, function operations, filter, low pass, high pass, band stop. Included in function operations is integer, difference, square root, large, linear, exponential, and ABS. Fixed operation is a combination of two operations. For details, please refer to the introduction in FX operation. Okay, you press math, then math operator in the vertical control area. So that's gonna be here, math. Press math, then math. And then choose operator. Okay, so there's all your math functions. Press operation to enable the operation. The result of math operation is displayed on the waveform marked with M on the screen. I don't see that. Math operator. I don't see the M for some reason. I don't know. I don't see it. I don't see the M. Okay, addition. Add the waveform voltages values of signal source A and B point by point and display the results. So addition would be here, the first one, subtraction, multiplication, division. So you can go through these and choose each source and then calculate. So that's what that's telling you. Subtraction is the second. Multiplication, division, FFT. So fast Fourier transform is used to transform time domain signals to frequency domain components or frequency spectrum. This oscilloscope provides the FFT operation function, which enables users to observe the time domain waveform and spectrum of the signal at the same time. FFT operation can facilitate the following works. You can measure harmonic components and distortion in the system. You can display the characteristics of the noise and DC power and you can analyze vibration. And that one is here. Oh, not that one. There. Okay. So you would select the source of your channel, then you would select the center frequency, and then the horizontal scale, then the vertical position, then vertical scale, and then select your window function. Okay. So it says you can choose under window function. It says rectangle is the best frequency resolution. The poorest amplitude resolution, similar to the situation when no window is multiplied. Blackman is the best amplitude resolution, the poorest frequency resolution. Hanning is better frequency resolution and poor amplitude resolution compared to rectangle. Hamming is a little bit better frequency resolution than Hanning. And accurate measurement of signal is flat top. And then triangle is better frequency resolution. It says for rectangle, you're measuring transient or short pulse. The signal levels before and after the multiplication are basically the same. So sine waveforms with the same amplitude and rather similar frequencies. Then you can measure wideband random noise with waveform spectrum changing relatively slower. For Blackman, you're using it to measure single frequency signal or search for higher order harmonics. In Hanning, you use this for sine, periodic, and narrowband random noise. And in Hamming, you use it for transient or short pulse. The signal levels before and after the multiplication are rather different. A flat top, you use this for signal without accurate reference and require to accurately measurement. And then triangle, you use it for narrowband signal with stronger interference noise. And that's under window functions. So that's what the ones I just read off to you. Oops. So those are the different types you can choose. Okay. You select mode, which is this one. And it has the option of trace or memory. It says trace is the data source of the FFT operation. Is the data of the waveform displayed on the screen. The length is up to 1200 points. The sample rate is the screen sample rate, namely 100 over a horizontal time base. Memory is the data source of the FFT operation, is the data of the waveform in the memory. And the length is up to 16,384 points. When the memory depth doesn't exceed 16,384 points, all the data is used for FFT operation. Otherwise, the instrument will read the data of 16,384 points according to the trigger position. The read rules is as follows. If the trigger position is before the start point of the memory, the instrument will read the data of 16,384 points from the start point of the memory. So memory mode is only available in YT time-based mode and not slow sweep mode. Okay. So next up you have your other operators. So I'm not going to go through each of those. They're pretty self-explanatory if you've worked with math functions before. So that is basically the chapter 6 is going through each of those. If you do want me to go through one of those, just comment below and I can pick it up later. Let's see if it has, let's go through filter, because I think that's useful. Okay, and filter has 4 types of filters: low pass, high pass, band pass, and band stop. The specified frequencies can be filtered by setting the bandwidth. So we've selected filter. Next up, we're going to select our operation to enable the filter, which is what we did under operator. Then you're going to press source to pick up your probe from whichever one you have it on. And then you're going to press the offset and use that to adjust the vertical position of the operation results. And then you can press scale and use that to adjust the vertical scale of the operation results. Okay. Then you're going to choose scroll down and then you're going to choose filter. So the first one is low pass, namely on only the signals whose frequencies are lower than the current cutoff frequency. The next one is high pass. So that's high pass. And that's only the signals whose frequencies are greater than the current cutoff frequency. The next one is band pass. It's only the signals whose frequencies are greater than the current frequency. And then the next one is band stop. Only the signals whose frequencies are lower than the current cutoff. So that's band stop is the last one. So that's your filters. Okay, next up we have when we press auto here, right here, it goes back to the auto menu. And this is quick measurement after you press auto. And this is single period, which when you press it, get back. No. It says it sets the oscilloscope to display single period signal automatically. Measure the period and frequency of the current signal within a single period and display the measurement results at the bottom of the screen. The next one is multi-period, and that sets the oscilloscope to display a multi-period signal automatically. It measures the period and frequency of the current signal within multiple periods and displays the measurement results at the bottom of the screen. So it's going to display it here is where it would display it. Next up you have the rise time, which is this one. It's rising. It measures the rise time of the current signal and displays the measurement result at the bottom of the screen. Next up you have the fall time. so it's falling. It measures the current signal and the display measurement result at the bottom of the screen. Then you have the back button. Returns to the menu. Then you have the undo button. Which is right here. And that cancels the automatic settings and restores the parameters set by the users lastly. Waveform auto setting function requires that the frequency assigned is no lower than 41 Hz. The duty cycle should be greater than 1% and the amplitude must be at least 20 millivolts peak to peak for square. Otherwise, the waveform auto setting may be invalid and the quick parameter measurement function displayed in the menu will also be unavailable. Alright, and that completes up to page 124 out of 211, so that's where I'm going to end today, and I'll see you back next time. Bye guys.